Imagine a silent visitor from the depths of space, moving faster than any comet or asteroid we've ever seen. It comes from beyond our solar system, crossing unimaginable distances, and then, suddenly, it begins to fade. NASA scientists are on edge. Telescopes trained for months now capture less and less light. What could cause an interstellar object to darken without warning? Is it a natural phenomenon, or something far stranger, a cosmic enigma defying everything we know about the universe? The void is never empty. Every speck of light we see is a story spanning billions of years. Yet, some stories are stranger than fiction. One such story is unfolding now, right in front of our telescopes. The object known as 3I/Atlas, only recently discovered, has captured the attention of the scientific world. Its very existence challenges what we thought we knew about interstellar travelers. Most objects passing through our solar system are predictable. Their brightness follows familiar patterns. Their paths obey gravity like clockwork. But this one? It's behaving differently. Initial observations were thrilling. 3I/Atlas appeared like a faint, icy wanderer gliding silently through the cosmic ocean. Early data suggested a rocky or icy composition, perhaps similar to comets from the Oort cloud. Scientists worldwide celebrated a new opportunity to study an interstellar visitor. Telescopes from Hawaii to Chile monitored every flicker of light, every minute shift in trajectory. The excitement was palpable. Then, the anomaly appeared. The object's brightness, its apparent magnitude, began to drop unexpectedly. At first, scientists thought it was a measurement error. Equipment can fail. Atmospheric conditions can play tricks. But as data poured in from multiple observatories, a more unsettling pattern emerged. The darkening was real. Not only that, but it seemed to accelerate. NASA's team quickly gathered for urgent discussions. Could this be natural? Maybe a dust cloud, fragmenting material, or some kind of outgassing effect causing shadows. All plausible explanations, but none completely fit. Some astronomers whispered about rarer possibilities, interactions with exotic interstellar particles, mysterious forces we don't yet understand, or even new physics waiting to be discovered. Meanwhile, the public began to notice. Social media buzzed with amateur astronomers sharing snapshots, puzzled by the fading streak of light. Headlines screamed, "Interstellar mystery." NASA scrambles as object darkens. But this isn't a Hollywood script. This is happening right now, in real time, millions of miles away. And here's the chilling part. 3I/Atlas is moving fast, and soon will be gone from sight entirely. If we can't understand what's happening before it disappears, this cosmic enigma might leave only data and questions behind. Something about this darkening is not just unusual, it's urgent. As scientists race to gather every photon, every piece of evidence, one question looms large. What lies at the heart of this mysterious fade? And could it be signaling something far beyond our comprehension? The answers, or the shocking revelations, are coming in the next chapter. The story of 3I/Atlas begins not in our backyard, but in the deep reaches of interstellar space. Traveling at tens of kilometers per second, this visitor has come from beyond our sun's influence, crossing light years of emptiness in a silent journey that began perhaps millions of years ago. Unlike ordinary comets or asteroids, 3I/Atlas's path was hyperbolic, meaning it isn't bound to our solar system. Once it passes, it will vanish forever, continuing its lonely voyage through the galaxy. Astronomers first detected it using automated sky surveys designed to spot transient objects. The initial readings were electrifying, a faint, fast-moving that didn't match the typical orbital patterns of solar system objects. Experts quickly confirmed it was interstellar, joining the ranks of only two other known visitors, Oumuamua and Borisov. But 3I/Atlas was different. Its brightness, speed, and trajectory suggested something unusual, something that made scientists sit up in alarm. From the start, NASA and observatories worldwide worked in coordination, monitoring its every move. Data streamed in from telescopes in Chile, the Canary Islands, and Hawaii, each image carefully analyzed. The object was moving too fast for leisurely study. Time was critical. Astronomers needed to understand its composition, its structure, and, most importantly, why it was suddenly darkening. As researchers pored over the initial spectra, they noticed hints of unusual material, elements and compounds rarely observed in solar system bodies. Could it be a remnant of a distant star system? Or was something even stranger, something engineered? Questions like these are normally speculative, reserved for science fiction. But now, even the most cautious scientists were forced to consider them seriously. Observers also noted its sudden brightness fluctuations. One moment, it shone faintly like a distant star. The next, it dimmed drastically. The rapid changes baffled experts. Natural causes could include dust jets or fragmentation, but nothing matched the exact pattern. Even more perplexing was that the object's darkening wasn't uniform. Some wavelengths dimmed faster than others, suggesting complex interactions at play. The urgency was clear. Unlike previous interstellar visitors, 3I/Atlas offered a fleeting window of opportunity. If we don't capture enough data now, the clues may vanish with it forever. For NASA, the question was no longer just scientific curiosity. It became a race against time. Every calculation pointed to one unsettling truth. This visitor is unlike anything humanity has ever studied. And as 3I/Atlas hurtles closer to the inner solar system, the next revelation may push the boundaries of what we consider possible in our universe. As telescopes worldwide tracked 3I/Atlas, an unsettling pattern began to emerge. The object wasn't behaving like any typical asteroid or comet. Its brightness fluctuated unpredictably, fading and brightening in ways that defied expectations. Even instruments designed to detect the faintest light struggled to capture consistent readings. The object seemed almost alive in its irregularity. Astronomers first suspected observational errors. Clouds, atmospheric distortion, or calibration glitches can make distant objects appear dimmer or irregular. But the anomalies persisted across multiple observatories. Data from Chile, Hawaii, and space-based telescopes like Hubble all told the same story. 3I/Atlas was darkening. Not slowly, not linearly, but in sudden dips that left scientists baffled. Some hypothesized natural causes. Perhaps it was fragmenting, shedding surface material in uneven bursts. Maybe dust jets were obscuring the light, similar to the behavior seen in comets. But none of these explanations fully accounted for the scale or speed of the dimming. Even the object's trajectory didn't indicate collision or breakup. Something else was at play. Spectroscopic analysis added another layer of mystery. Different wavelengths of light dimmed at different rates, suggesting that the fading wasn't simply a matter of dust or ice reflecting less sunlight. It hinted at a complex surface or possibly an interaction with an unknown interstellar medium. Could the object be cloaked, intentionally or otherwise? Scientists debated quietly, careful to separate speculation from the limited data at hand. Meanwhile, radio telescopes detected weak but irregular signals from the direction of 3I/Atlas. They weren't structured like a message, but they were consistent enough to raise eyebrows. Could this be some kind of outgassing? Could it be an unknown physical process producing electromagnetic interference? Or, as some daring theorists suggested, could it be evidence of something artificial, an object built rather than born? As the world watched, even amateur astronomers joined the chase, capturing streaks of light and sharing photos online. The fading light of 3I/Atlas became a visual reminder that we were observing something rare, something transient, and perhaps something that could challenge our understanding of the cosmos. The pressure on NASA and other space agencies intensified. The clock was ticking. 3I/Atlas would not linger forever. Within weeks or even days, it could fade completely beyond the reach of our instruments. Every observation became critical, every photon precious. And yet, for all the advanced technology and decades of astronomical experience, one haunting question remained. What exactly is happening to this object, and why now? The answer, whatever it may be, could reveal secrets about interstellar space, the nature of cosmic bodies, or phenomena we have yet to imagine. As the mysterious darkening of 3I/Atlas deepened, some scientists began considering possibilities that were normally reserved for science fiction. The idea was radical. What if this object wasn't natural at all? What if it was engineered? At first, it sounded implausible. Most interstellar visitors are fragments of distant star systems, icy and rocky remnants ejected by gravitational forces. But 3I/Atlas wasn't acting like any known comet or asteroid. Its shape, inferred from brightness fluctuations, seemed elongated, irregular, even suggestive of a hollow or reflective surface in some analyses. The fading pattern was unusual, almost too precise to be purely random. NASA researchers began modeling scenarios that included artificial structures. Could it be a probe or a craft, perhaps traveling for millennia from another star? Could its dimming be deliberate, a way to avoid detection as it passed through our solar system? The questions were speculative, but the data demanded attention. Ignoring them could mean missing something unprecedented. Even more curious were the electromagnetic anomalies detected in conjunction with the darkening. Weak signals, intermittent and inconsistent, seemed to originate from the object itself. While no coherent message was detected, the pattern was unusual enough to be considered non-natural by a small group of theorists. Could it be a beacon or a byproduct of technology far beyond human understanding? Other possibilities were explored. Perhaps it was a natural object with unusual properties, an interstellar shard containing reflective minerals or volatile compounds that behave in ways we've never observed. But with every observation, the case for the unknown grew stronger. The fading wasn't random. It had a rhythm, a signature. Even the most cautious astronomers admitted something about this object was defying explanation. The implications were staggering. If 3I/Atlas were artificial, it would be the first tangible evidence of intelligence beyond our solar system. Every scientist understood the magnitude of that statement. And yet, the object remained distant, moving at high speed and fading fast. Humanity had only a narrow window to study it. Within NASA, debates raged behind closed doors. Should they escalate this to public awareness? Should warnings be issued? Or should the observation continue quietly until more concrete evidence could be gathered? The uncertainty only added tension to an already unprecedented situation. For the world outside the observatories, the object remained a faint dot in the sky, mostly invisible to the naked eye. But for those monitoring it, 3I/Atlas was more than a dot. It was a puzzle, a cosmic enigma that could challenge our assumptions about the universe and our place within it. And as scientists scrambled to understand it, one chilling thought lingered. If it is artificial, we are witnessing a visitor older than human civilization itself, and it may not want us to see it at all. Don't forget to subscribe, like, and comment. What do you think? Is 3I/Atlas a natural interstellar rock? Or could it really be something artificial? Could we be seeing evidence of extraterrestrial technology? Every observation of 3I/Atlas is a clue, every photon a potential key to understanding its nature. But as the data accumulated, astronomers noticed something even more puzzling: subtle, irregular fluctuations that didn't match any known cosmic pattern. Light curves twisted unexpectedly. Spectral lines shifted. Tiny pulses appeared and vanished without warning. These ripples in the cosmic data suggested that 3I/Atlas was not a passive object drifting through space. It was interacting with its environment in ways we could barely comprehend. Scientists began comparing the observations with other interstellar visitors, like Oumuamua and Borisov. Both had offered valuable insights into how objects travel between stars. Yet neither exhibited this kind of variability. Oumuamua had mysterious elongation and non-gravitational acceleration, but did not show these complex dimming patterns. Borisov, a comet, behaved largely as expected. 3. I/Atlas, however, seemed to defy classification. Some theories leaned toward natural causes. Could it be shedding material in uneven bursts? Could interstellar dust clouds or magnetic fields be affecting the object's brightness? Perhaps radiation pressure was causing transient effects, but the models couldn't fully reproduce the observations. Every calculation left residual anomalies, tiny, unexplained ripples that demanded explanation. At the same time, astronomers noticed that these fluctuations appeared to carry patterns, subtle periodicities in the fading and brightening of certain wavelengths. They weren't signals in the traditional sense, not yet, but they hinted at structure. Could this be random noise, or was there an underlying mechanism producing the pattern? Was 3 I/Atlas silently communicating through the very light it emitted or reflected? Radio telescopes also joined the investigation. While no intelligible transmissions were detected, weak bursts of electromagnetic activity aligned roughly with the light variations. These bursts were faint and irregular, but consistent enough to attract attention. Some researchers suggested they might